Hi guys, my name is Kristian Kirapas. I am the president and co-founder of Web3 Philippines, and in today's session, we are going to talk about and jump off from our previous session wherein we were talking about native Solana smart contracts. But for this session, we'll strive to do 2 hours max, so it can be less than 2 hours, but it's gonna be we have at least 2 hours max, so we have enough time to take it slow and go over the topics that we're gonna discuss today. So before we get into that, I want to see some comments over there of who are with us today. GM, France, Egos. You were there last time as well in our previous session. So GM. Okay, hopefully a lot of you guys will be able to learn a lot from today's discussion. Yeah, I'll be sharing my screen in a while, but what you guys can see is I'm building our program for today that I will be demonstrating for you. All right. So if you're there, please comment GM. I'll be waiting for you guys. GM. Okay. So let's wait for other people. Franz, if you're there, what are you most curious about in learning today? Especially since I know you're a Solana enthusiast as well, and you're excited about Solana engineering. What are you excited to learn about today, and what are some questions in your mind? Yeah, so let's start there. Let's start there. Okay, I'll wait for France while I'll spin up this diagram. Okay, so let me share my screen. Let me know if you guys can see it. Ta-ta-ta. Okay, is it visible? Okay. So Franz Egos has a question before we start. He's asking, should I master Rust before diving into Solana development, or surface level is just enough? Okay, so here's what I'm going to tell you, Franz. When it comes to Solana programs, okay, when it comes to Solana programs, I do encourage you to go and reach a point into your Rust where you can create your own server. So you create your own backend with Rust. At least you get to that level first before you dive into Solana. The reason being is because Solana is a different beast altogether. It has different constructs. It has different things you need to think of. So trying to learn Solana while also learning Rust is hard. So I recommend na you learn Solana. I learn Rust ahead. At least learn how to have a server with Rust. That's sufficient enough. Then learn the rest while you're building with Solana programs. Okay, because if there's one thing that really helped me a lot with Solana, native Solana, right? There are two types of Solana programs. One is Anchor. The second one is native Solana. That's purely written in Rust without any frameworks. Okay, is that learning Rust ahead helped me so much more deal with the problems when it comes to Solana because I already knew what Rust was capable of. Hi Ron, Ronaldo Lipata, brother, what's up? What's up? Happy that you guys are here, Ron. Since you're here, the same way with France, I have a question for you. While we wait for the build to complete, uh, for some reason my PC is so slow today. But Ron, do you have a question regarding Solana, Rust, blockchain engineering that you want me to answer before we go and deep dive into native Solana contracts and programs? Franz, you as well, if you have more questions, this is your moment. Because I know you're busy with a lot of work. So I want to hear from you guys before we start. Because it's hard. It's hard. If you don't learn Rust. Like start with Rust first. If you don't learn Rust first, it's gonna be it's gonna be painful. It's gonna be painful. I tried it. All right, I tried it before. I learned Rust, but I tried not going deep into Rust first before going into Solana. It was painful. Okay. All right. So while we wait for Ron's questions, shout out to you guys. If you are here, please comment GM so I know who to ask questions from and get interaction from in this session for today. Now, there's three things that I need you guys to understand when it comes to Solana programs. And I'll show you here on a diagram. Okay. So let's go. Ronaldo Lipata. So Ron asked the question. All right. Sabi ni Ron said in English, because we do have international viewers today. What is better to learn first? Native Solana or Anchor? Really good question, Ron. It's a really good question. All right. When it comes to Solana programming, I recommend anyone to start from native Solana. Don't go directly to Anchor. I know that's controversial because a lot of people say, oh, Anchor is easier. Anchor is great. You need to go straight to Anchor because that will help you get started fast. No, because what Anchor does is it abstracts or make things easier for you at such extent that once you go there, once you reach that point, once you use Anchor, you don't know what's happening underneath. All right. The problem with frameworks or abstractions in general is that it makes it so much easy. You don't know. It's like you're not aware of what's the inner workings. But going first with native Solana will help you understand, at least on a sequential, one by one, step by step, or imperative flow, how a Solana program works. All right. So what's up? What's up? GM, Ashley. I hope that helped. Ron. If you guys are here, please say GM and share your questions so I can answer them today. Now, going back to the diagram I'm going to show you today. So I'll show you my screen right now. Okay, let me expand the screen and make it bigger so you see it. There we go. Beautiful. So the first thing you need to understand, like last time, I've shown you guys, okay, when it comes to Solana, it's what we call the program interaction, right? So how do you interact with the program? Usually it happens like this. A user will interact with a program. Okay, and then it will give you a result. How does it give you the result? By the user, okay, requesting the data from the program. Okay, so that's how it works. The first thing that occurs is hey, do this. All right. How do we tell the program to do this? We use what we call instructions. Okay, so a single unit of execution in Solana are called instructions. All right. Now, when it comes to data, what do we call it? We call it query. Query or fetch. We query data or we fetch data from the program. All right. So that's the basic format of a Solana program interaction. Now, if we go deeper on how this works, it goes like this. Let's go deeper. Let's get the basic format of a Solana program interaction. Actually, you know what? Let me duplicate this so that we can go back to it later. Is instead of you using just instructions, you're actually using a transaction that holds your instruction. Got it? So it's actually a transaction that holds your instruction. And then, not only that, there are very important steps you need to do before you even communicate with the program. And what is that? I discussed last time. So I'm going to test you, Franz, Ron, Ashley, Warv, everyone who's there, I see you guys. What did I teach you last time regarding what happens before we interact with the program? Okay, let's see if anyone remembers. I'll wait for you guys for 10 seconds. 10, 9, 8. Let's check our build. Okay, beautiful. It's already built. Nada? Okay. So the first thing that happens is before you even interact with the Solana program, you must first pack data. Okay, so here's what's going to happen. The user will interact with a DApp. So we have a DApp. Okay, then this DApp will pack your data. Let's use in flowchart. A process is usually a parallelogram. So let's use a parallelogram. Okay. It will pack your data, pack data. Right? After it packs your data, it's gonna attach your data to a instruction, tap N with data. Oh, let's put it that way. Instruction with data. Then once you have the instruction with data, you do a transaction with the program. Okay, let me zoom out a bit so that we can fit that. You finally do a transaction with the program. Okay, so once again, let's recap what happens when you interact with the Solana program. You first interact with the DApp. The DApp will pack your data. So it will pack your data and make more data. Lots and lots of data because it packs your data. Anyway, going back, you pack your data, okay, and then you attach your data to an instruction. And once this is done, you attach your instruction to a transaction, and then you send it to the program. Clear? Everybody say clear if it's clear. I'll wait for you guys. Let me know if it's clear. Franz, Ron, Jules, hi Jules, Ashley, Web3 Philippines, guys. Let me know if it's clear. Then, okay, Ashley said it's clear, but it's not that simple. This is where we start going into serialization, which Franz mentioned. All right. So the thing with sending data over the internet is because you can't really send data over the internet without serializing it first. So without turning it into bytes. Okay. So the first thing you need to do is to serialize this data and send it to the program. Okay, so don't forget that we're serializing data. Now, I want to show you guys how it's done in Rust. So I'll go each phase and go over Rust and then discuss with you the whole picture at the end. But first, let's start with a user interacting with the app, packing the data and into an instruction data, attaching to a transaction, and then sending that to the program. Okay, so I'm gonna show you how it's done. First, let's go into our code. You know this. You're not new to this. Okay, so this is our example of how it happens. So first, I create a program. All right, so this is what I do here. I first create a program. Let me zoom in. Is this that's clear? I simply create a program first. All right, and the next thing I do. Okay, let's go back to the diagram. So let's find the place where we pack the data. Okay, where we pack the data. So going to our code, you can see here. I create an instruction as you see here. This is the instruction. And based on the initialized instruction, we don't need any data. Okay, we don't need any data as opposed to, let's say, we both don't need data here because, for example, initializing, you don't really need to give a data. Incrementing, for example, you don't need data to increment because it's just plus one. Okay, so in this part, we're packing the data. And how do we pack it? Come on, what's the keyword? Starts with the letter S. How do we pack this data and make lots of data babies? Come on, how do we pack this data? Starts with the letter S. I'm waiting in the comments. Let's see who will answer. Web3 Philippines? Web3 Philippines answered serialization. Okay, you're correct. All right, sheesh, good job. I'm gonna give you a thumbs up. Okay, it's the thumbs up is too big. Let me zoom out. I'm gonna give you a thumbs up. Good job. All right, once again, sheesh, it's serialization. Okay, good job, Web3 Philippines, for answering our question. Whoever is behind. All right, so going back, let's go back. Let's zoom in again. We pack our data with serialization. And then what next do we do here? What do we do here? Any ideas? I'll go back to the diagram so you guys can see. All right, I'm gonna put it side by side with the code in hopes that it helps. Yeah, the screen is too big. Okay. Okay, so what are we doing here? Any guesses? It's too small. We're actually attaching our packed data into an instruction, as you see here. All right, so in Solana, IX is actually instruction, like instruction. All right, that's why it's IX. For those who don't get it, why it's IX. So this is an initialized instruction that we pack into through serialization. Then we attach to a transaction. Okay, we attach it to a transaction, as you can see on the screen right now. And after we attach it to a transaction, we finally send it to the program. Clear? Everybody clear on that? Could you guys say clear if it's clear so we can proceed to the other part of Solana? Okay? Because the first thing that happens, once again, is that a user, on a very simple level, the user would send instructions to a program, right? That's the first thing. And then this, when we zoom in, it's actually a user interacting with the DApp, then DApp packing your data to create many data babies. Okay, because you pack the data once again. You attach it to an instruction, and then this instruction you attach to a transaction and send it to the program, which is on chain. Okay, can I hear any clear from the audience, from our comments? Let me know if everything's clear so far, so we can proceed to the next part. Franz Ego said, Elmao. Lamao. Data babies. For the win, data baby. Because we pack the data, so we make data babies. All right. So Ashley Ochenko said it's clear. Now, of course, after sending the data, what do we need to do? We need to go into the program. So let's assume we're going into the program. Let's teleport. Zoom. Okay, we're finally in the program. Let's assume we're already in the program. All right. What do you think will be the first thing a program does? Okay, so we're way past the program. I'll give you a clue. It's the reverse of making data babies. What do we do? Okay, once the program receives our transaction, what happens? Confirmation? Not quite. It's the reverse of making data babies. The serialization, all right, exactly. We basically stop making babies because we unpack data. Okay, we no longer pack data, so we no longer have data babies. Hi, all right, because we unpack data through what methodology or what technique or what process do we call this unpacking? Everyone, can someone give me the word? Ron did. It's called the serialization. Okay, everyone. So once it arrives to the program, we deserialize the data. Okay. Then after deserializing the data, what do we do? What do we do with the data after we serialize? Okay, any ideas? There's two more steps. Actually, there's four more, but we're not gonna talk about one. The one in the middle. Okay, I'll add this here. There's a step here. It's called validation. But today we're not gonna discuss this because it's a totally different beast. So Ron said validation. You're right. It's actually next to unpacking data. We need to validate for sure, 100%. But we're gonna skip that talk today because it's a big topic. So what's next? After you unpack, validate, what's next? Let's make this data. Wow, beautiful. Okay. We call it business logic. Okay. What do you mean by business logic? In simple terms, it means, bro, do what you gotta do. Okay. Do what you gotta do with the data you receive. Okay. We do our business logic. Recap, we send our data to the program. A user sends an instruction to the program receives the instruction, the program deserializes or unpacks the data, we validate, okay, just to make sure everything's good, then we do our business logic. Basically, with the data that you have, do what you need to do. For example, if you got numbers and your program does add, let's say you have an addition program, once you get the data, then you add things. All right. So for an add program, for example, we have an add program. And let's say let's track it. All right. I'm gonna name this program. Then what I'm gonna do is I'm gonna show you guys, let's say add program. Okay, so we unpack the data. We add this here. I'll make it bigger so you guys see it. So we send data. This is how it looks like. Okay, we send the data to the internet. This is how it looks like. It's because it's serialized, right? It's random gibberish. Then we unpack the data. What comes out after we unpack the data? Okay, real numbers. So for example, the user, okay, a user wanted to add two numbers, for example, right? Let's do an addition of, let's do add 1 2. Okay, for example, that's your instruction. add 1, 2. What we receive on the other end is the serialized data. We unpack it, and at the end, we get what? We get 1, 2, because it's already unpacked. Okay? Then we do our business logic, so we add 1, 2 on chain. All right? So this is business logic. Let me color them so you guys see it. Okay, are we still clear? Let me move this entire diagram at the bottom so it doesn't clash with our, Oh, okay. This is important. I know this isn't exciting because we're not writing the smart contract yet or the program yet, but this is important for you guys to understand that when a user sends an instruction to the program, it will serialize. Then once it's on the program, it will deserialize the data. Okay, it will deserialize the data, unpack the data, get that data, and do the business logic. And what's the last step that would occur? Okay, what's here? Let's color this orange. What's that? What do you guys think? What's the last step? If this is if this is business logic, this is unpacked data, what's the last step? Any guesses? I'm watching the comments. I'll wait for you guys. Damn, it's not straight. Let it be. Any guesses? I'll wait for the comment. France, Ashley, Ron, do you have any guesses? What happens after business logic? Clue. Okay, it starts with the letter S. The second word starts with the letter S2. All right, I'll give you guys a clue on the code itself, on what it looks like. It's increment. I think increment is the best. It's in processor. Process increment. Okay, so here's the clue. You can see it here. Starts with the letter S. The first word, second word starts with the letter S. After we do our business logic, what happens next? Okay, the answer is we store state. All right, we store state. Got it? So what happens here is we store our data or our result on chain. Okay, we store a result on chain. So in this case, this would be, what's the result of this? It's 3, right? The result of adding the business logic is 3. Then we store 3. Okay? Store 3. Got it? Okay, so that's what happens. Recap, once again, the first thing that occurs, very simply, is a user interacts with the program by sending instructions to the program. That's the first thing. If we look closely how this occurs in the real world, it's actually I, as a user, will interact with a web application or a decentralized application. And then this decentralized application will pack my data and create many data babies. Okay, a lot of data babies. Hi. Then once the data is packed, it's attached to an instruction that is attached to a transaction and sent to the program. Now, after it's sent to the program, we go to the program. Wow, let's zoom out, bro. Okay, we go to the program, and what? We unpack data. Okay, we do the business logic. and we store the state, which is in our example, if we want to add 1 plus 2 to our program, deserialize our program, unpack it, we get 1, 2, we add for business logic, we add our data, then we store the state on chain. Okay, so very, very simple on how it works. Now, okay, I'll show you how this works on program level on the already created program. Then we're gonna create a program, an other program that's not yet created. I'll show you how it's done from scratch. All right, and I hope we have good enough time, 1 hour and 30, to show you how it's supposed to occur. Okay, so program side, right? I'm gonna show you on the program side. Let's fit some code, or is it too small? Might be too small. Let me increase that. This better? Better? All right. So for everyone here, guys, we're already 30 minutes in. Please like and share our stream so that more people can learn how to write native Solana programs or smart contracts. We hold this session, our Web3 Classroom sessions, every Thursdays, 8 p.m. And our mission is to onboard as many of you guys with our skills and expertise in blockchain engineering in hopes that you as well tap into the industry and become professionals in our field. Okay, so I'll show you how it works. So the first thing that occurs is we process the instruction that the program receives, as you see here. All right. And when Solana sends a transaction to a program, it actually sends three key pieces of data. All right. The first one is the program ID. Basically, you can think of the program ID as the name of the program. Solana knows a program by its program ID. So if we send a transaction with a program ID, okay, with the program ID, Solana knows where to send the instruction. So in our last diagram, it's not actually just this. Okay, it's not just add 1, 2. It's actually this. Let me show you. In the real world, this is how a Solana transaction really is. It has the program ID. It has the accounts that you will be modifying and needing. And it has what? It has the instruction data. All right? And the instruction data, let me bring this guy further, move away from the program. The instruction data is the data that you deserialize. So it's this. It's this. Okay? So this entire thing comprised of what? A transaction. Damn, my tea is tipsy. All right, so that's how it is in the real world. Now, going back to the code, after Solana sends the program ID, the accounts, and the instruction data, we now deserialize. So this line deserializes the instruction data, as you can see here. It deserializes the instruction data into a counter test instruction. And currently, in this program, we have two possible instructions. Number one is to initialize and to increment. So what we do here is we say, hey, the instruction is the deserialized version of instruction data. Okay, so this is what This line says that, hey, the instruction is the deserialized version of instruction data. And currently we have two possible, initialize and increment. Now let's say, for example, we did initialize. Okay? Let's say, for example, we sent the initialized instruction. Here's how it's going to go. We process the initialized instruction. So let's go to the process, initialize instruction. Okay? Then after deserializing the data, what did I mention is the first thing we do? We validate. So as you can see, I do some assertions to make sure I validate the data. If the data doesn't match as expected, it will fail. So make sure to validate your data. But after validating your data, what you can see here is we're finally in a stage where we do our business logic. Okay? For an initialization instruction, what are the two key things that we need to do in Solana? The first one is to create a data store for your data. All right, so as you can see here, we need to tell Solana, hey Solana, please create a data store for me to put my data into. If we don't create a data store, it will error. All right, so for example, I'm gonna demonstrate to you guys how it will error. This entire thing, how I'm not sure if my Limelight works. Fuck, doesn't work. But this entire code, right? The invoke sign, as you can see here, create account. Tell Solana create an account. But what happens, as you can see, if I remove it? Let's try to remove it. Let's not create a data store or an account in Solana. So first, let's test that it's working. It's passing. Okay, now the code is good. Everything is all right. If everything is good, it's working, it should say pass. And let's wait. Do you guys have questions? Please comment them down below. Okay, what do you see here, guys? You see that it's passing. All right? It's saying, oh, everything is okay. You've done everything right. But let's say, for example, I don't create an account. I don't create an account for my data to go into. Okay, so I delete this. All right, so I delete that. I delete the entire instruction that was responsible for creating my data store. What happens next? Do you think it will pass? Let's try. Wait and see. It failed. Why? Oh my God. We didn't expect it to fail. Why? Why did it fail? When I removed the instruction or the part of our code that was telling Solana, hey, create a data store for me. Okay? Why do you think so? Why? Because maybe you can see the logs, or maybe it's too big. Okay, I'll show. Here's the error message, guys. It's here. Actually, it's just hard to read. Oh, here. What's written here is failed to serialize or deserialize account data. Why? Why do you think so? Any guesses in the comments? Why do you think this failed? Okay, why do you think our instruction failed? Any guesses? This is a really interesting part. We're gonna go deep into this part. So I want to hear thoughts. Why do you think it failed when we remove the data store code or the part of our program where we tell Solana, Give me database. Okay, give me space on chain. I want to store my data. Okay, give me that. Why do you think it failed? Okay, I'm reading the comments. Any guesses? Any answers? While I wait for people, here's what I'm gonna do. I'm gonna put that code back that creates an account or a data store for us in Solana. I'm gonna save it and I'm gonna run it again. I'm gonna run our tests. And if everything happened right, you guys must be able to see that what it now passed. Because going back to our lesson, okay, I need to emphasize this part. All right, we need to emphasize this part because this is important. Before you even store data, okay, let me duplicate this. Before you even store data, okay, let me make that dotted because why not? You first need to what? Create an account or also known as a data store. All right? Before you even store your data, you first need to tell Solana, give me space. Where the hell do I store my data? Okay? So in reality, we don't go from add and go directly to store. We must first ensure we create the data account somewhere. Okay? So it could be, let's say before I even do the add, I can create the data already. It will still work. Totally fine. All right? Totally possible. Or if I want, I can do it before I store it, as long as you create the account before you store your data because it will fail. All right, so let me mark this as color. Damn, we ran out of colors. Hi, blue. Sige, let's do blue. Okay. Recap. Walang account or user. Okay, very good, Ash. I'm gonna show you guys later how it works. So recap. How do we store data, or how does a program interaction work on the program side? For an add program, for example, a user sends an add instruction. Okay. The program receives the serialized data. We unpack the data. So there are no data babies here. No data babies because we unpack. Very sad. I'm very sad. Uncle Roger is sad because we unpack data. No more data babies. All right. So after we unpack, we do our business logic. So in this case, we add. Then after we add, we create an account or data store. Then we store our data there. This is the most important part that we need to discuss. Okay, so here's how it works. Programs in Solana, okay, a program in Solana is actually what we call stateless. Your data is not stored on the program. Okay, your data is not stored in a program. Instead, in Solana, your data is stored on a data store. That on Solana, we call them formally as accounts. All right? So there are a lot of different types of accounts in Solana. But for this part, in order for us to store data, we need to have what we call an account. To store the data that is what? Attached to a program. All right? So we create a data store that's attached to a program. So the program is stateless because your data is not on the program. It's not. Your program just knows what is the name of your data store. It knows what data store your data is stored into. That's how it works. But it's on a totally separate account. Okay? An account in Solana comes in different ways. There are what we call normal user accounts that has a private key. The user that we used to pay with. We have what we call executable accounts, also known as programs. These are the smart contracts, accounts that can be executed or ran. And the next is data store accounts, okay, where we store data that is attached to a program. Capiche? Get? So Ashley was asking a question. He said, are there no accounts or users from the user? Right? From the user. Okay? The answer is there is. There is a user account. And it's actually passed via the transaction here in the accounts data. Okay? Now, I can show you that here. So we were sending a transaction, right? A while ago, we were sending a transaction. Here, this is the transaction. And you can see that in their accounts, here in this line, if you can see it, this line, let me add space so you can see it clear. This line is a list of accounts. And you can see that the payer or the user account is there. So the DApp does this for you. It creates the transaction that you need to interact with the program. Okay? Now, here's another interesting fact about Solana. A program is an account. All right? A program is an account. A data store is an account. A user is an account. So everything in Solana is an account. All right? The basic atom or representation of an entity in Solana is an account. Okay? Now, for a specific type of account called the data store account, formally in Solana, you will interact or rather discover this term a lot of times. In Solana, you'll see it a lot. It's called PDAs, also known as Program Derived Address Account. Okay? A data store in Solana is called a PDA, a Program Derived Account. Okay, it's a very crazy term that a lot of beginners would suffer hearing it because it's bro, who would ever thought of PDAs or program derived address as simply just a data store account in Solana? All right. So recap. Programs are also accounts. They are executable accounts. Data store accounts in Solana are called program derived address accounts or PDAs. Now, this is important for me to show you in code. Okay, so what makes it program derived? All right, let me find out. It's here. Okay, so in Solana, there is a in Solana, there are two functions we use to create data store accounts, and it's called create program address or find program address. If you see these instructions, it simply means create a data store account for me. That's it. That's what it means. And they're called PDAs, program derived addresses. So now, if people interact with my program, let's say if I interact with the program, it will create a data store for me in code. Okay? So it does that, creates data stores for me. And all of these are attached to the program. Okay, that's how it works. Oh, let me undo ugly. All right, so that's how it works. How data is stored on Solana. Programs in Solana are stateless. Your data is not stored on a contract or a program. It's stored on a program derived address or PDA that is attached to a program. And how is it attached? Like this. In a find program address instruction, the function we use to find PDAs, you can see that we pass in what? What can you see? What's the arguments of a find program address? Okay, what are the arguments? Anyone? Ash, Ron, Franz, any insights? What do we use to find the program address? It's a second parameter. Say it in the comments so I could see if you guys are still here with me and verify if you guys are still here with me. It's what? Starts with the letter P. Come on, Uncle Roger, waiting for you. Comment, what do we use to get the data store? The program ID. The Franz Ego said program ID. So I'm going to give a quick shout out to, oh, it's there already on screen. It's called program ID. So I'm going to put it beside this thing because Franz did a really, holy crap. How do I, okay, I'm going to put it beside here. Franz, good job. How can I zoom in? So it's program ID. Now you guys are getting that program derived address is derived from the program ID. So because a program derived address or a data store account is derived from the program ID, we know that it's always attached to what? A specific program. Okay, so how do we know it's for that program? Well, because when we were creating it, when we were creating the address for it, we know that we use the program ID. Okay? So from there, we know that these data store accounts are derived from this program because we use the program ID in finding the program address. Very simple. Very, very beautiful, Franz. You are solid. I love you. Thank you. Thank you so much for answering that question. Okay? Now, we know how to derive a Solana data store from the program ID with a built-in function in Solana called find program address or create program address. But the key distinction here is that we're actually just getting the address for now. We're not yet storing data, or we don't have a data store yet. Okay? In what way? Because we just got the address. So what do we do to create a data store? Going back to I think it was process initialize. I think it was, yeah. So it was process initialize. What do we do? Okay, we create the address, the counter PDA. Then, okay, we create an account for it. So we now have the address, then we create an account for it. All right, so that's the step in creating a data store. Recap, once again. And Ali, hi Ali. Thanks for coming to our stream today. So Ali is owner of a really good company that we work with. It's called Lilypad. Lilypad is a decentralized compute layer for most AI use cases. At least we believe AI is one of the best use cases for decentralized compute. You guys check it out. It's actually here. It's called Lilypad on our docs. Check it out here. It's called Lilypad. So you guys go and check it out. It's a big thing. It's very interesting. It's something that I love working on. So I'm really grateful for you, Ali, for coming into this session today. Although it makes me shy a bit, but it's okay. It's all right. just be me. Okay, so going back, right? Quick recap of what happens when you create a Solana, when you interact with the Solana program. Okay, let us slow down, take a deep breath, and go over the steps. A user would interact with an program. The data that they sent is in a deserialized form. So when we enter the program, we need to what? Unpack the data so that our program can get it and understand the data that you sent. Okay? Now, after we unpack the data, we do what? Our business logic, which is the green one. We add, right? Then after we do our business logic, we create our account or data store. Then we actually store the data, which the last three parts you can see here in process, initialize, counter, PDA equals here. Okay, so after we create the account, we update the state and we store it again in our data account. All right, so that's it. That's the flow of how it works. Now, here's the next challenge we're going to tackle. Okay, so I know this is hard because coding on the spot is, it's not cute. There's a lot of things that occur when you do that because a lot of questions you need to answer. But because I really want to hammer this in to you guys, I want to show you how it's done from the get-go. So Ron was asking, can we get a copy of the diagram? Oh, most definitely, Ron. We will publish it for you. All right, make it cute. But it all starts here. First, we install the Solana tool. Okay, so we do Solana install. You can see that under documentation. Once installed, you check if it's working. So as you can see, I have 1.18 installed. Now you install the Rust tooling via Rust up. And you check once again if Rust is installed. As you can see, I have 1.79 on my computer. Now, when you have that installed, you create a new Rust project, specifically a library. So it's not a binary. All right, this is what a binary is. Let's say hello. Okay, we create a new hello. A binary is something that we run. Okay, our device runs it. But a library, on the other hand, is something that we package so someone else can run it. In Solana, we need the library. Why? Because the operating itself is Solana. Operating system itself is actually Solana. So it's not our computer that's going to execute our program. It's Solana. So we create not a new binary, but a new library. And let's name it add. Let's name it add. Okay. So I'll go to add. Okay. There we go. Let's check the files. What files are present? We see that there's only two files. The first one is our manifest. It contains the data about our project or our program. And then our main entry point, which is called lib.rs. It's our main entry point. Okay. Solana has its own entry point per se. So we're not going to use this because Solana has its own entry point, and it's this. Let me go back to counter test. Counter test is I think lumberjack would be good. I'll get it's okay. I'm just getting the entry point, right? So Solana has its own way of structuring a program. So, which I will show you guys right now. Okay, so this is the bare bones of the Solana program. You guys can even ignore this actually. For now, you can ignore that. That's the starting point. Okay, but of course, after you have the starting point, you must install what is needed. So what I'm going to do is I'll install what is needed for me to create a Solana program. So let's run Rust's install instruction or command. So I'll name it cargo add Solana program. So we need the Solana program. We need Borscht for deserialization. What else do we need? I'm thinking. Nothing else. I think we're good. I think we're good. Yeah, we're good. So we only need those. The Solana program, as you can see here, that we're importing. All right, in this line, so we're importing things from the package named Solana in Borscht. Okay, so it's finally done. The error should resolve in a while. Yo, installed it. What you man? What you man? Well, let me go back. Let me move hello, add outside. Let me go back to add. There we go. So that's the first thing that you do in Solana. You create a new project, you install the dependencies, which is Borscht and Solana program. Okay. Hope you guys are still following. Now, the next thing we're gonna do is we're going to determine what instructions we have for our program. And we're gonna do this via an enum in Rust. All right, so this is finally the point where we start realizing why learning Rust first, at least to a back-end server level, is important. Okay. Am I still here? Still good? Warm, if you're there, can you confirm if I'm still connected? Because I think I disconnected a bit. All right, I'm gonna see. Just wait. Confirming, guys. Yes, yes. Okay. Perfect. The first thing we're gonna do, identify what's our instructions. All right, what are our instructions? Not interesting. I'm a bit lagged. Warv, is the audio clear? Because I'm okay if it's lag if our attendees today are able to at least understand what I'm saying. Audio clear. Okay, perfect. I hope you guys are okay if I'm lagging. I don't know why. Maybe it's because of my machine. Maybe there's a lot going on in the background. But yeah, going back, we need to identify what are the instructions we're gonna need. For most Solana programs, the first instruction you need is simply a what? An initialized instruction. Okay, so let's name this add instruction, or let's say program instruction. Then let's name them two instructions. The first one is we want an initialized. Oh, I'm lagging. Is an initialized instruction. And then the second one would be an add instruction. Okay. So we'll have an initial instruction and an add instruction. Now, we're going to get that through what? The instruction data. It's going to be here. Okay. We're going to know what instruction it is with what? The instruction data. Wow, beautiful, awesome. Okay. So what do? We deserialize the instruction data. And how do we do that in Rust? We use a package called Borscht. Okay, this package, because it has built-in serialization and deserialization. So what I do is I go in and call let instruction to be the try from slice, okay? This simply means, okay? This simply means I'll write it first. This simply means take the instruction data and try to create a program instruction from the instruction data. But as you can see, it's erroneous. Why? It says it's not deserializable. Why? Because we need to tell our program that program instruction is something we can deserialize. Okay, and we do this in Rust such as this way. So this is Rust specific knowledge. Once again, this is a point where we all realize, oh my God, we need to learn Rust. Hi. But trust me, if you go over the hurdle of learning Rust, it gets easy. I swear. At least every single language you're gonna do Golang, those languages, Python, they're gonna become easy. All right. So you tell your program that the program instruction enumeration is deserializable and serializable. And you do this with a derived macro, which you learn if you learn Rust. All right. So now, what we have here, look at the type. What we have here is a program instruction. Okay, we now have a program instruction. But a program instruction can be two things. It can be an initialized or an add. So what are we gonna do if it can be an initialized or an add? We determine if it's initialized or add. So we ask, okay, we check instruction. You know what instruction? Let's match you, okay? Match instruction, and let's determine, am I program instruction initialized? Initialized? Okay. Or am I a program instruction add? Because it's two things, all right? So, which of which? Okay. So, we use this to determine which of which it is. Now, let's say, for example, let's start with to do, or the initialized instruction, I mean. In the initialized instruction, let's create a bracket so that we can add more lines. Okay, so I'm lagging. Come on, laptop, work with me. Oh, there we go. We're back, everyone. GM, IT Renzo. Okay. What do we do in our initialized instruction? Okay, we have an error. Okay. Immediately the reference, no need to add the unreachable because all diverge. Because we have to do. Yeah. I think if we have like a print ln here, it should be good. Let me just test that out. See if our error is beautiful. Okay, so for the initialize, here's what we're gonna do. I'm first gonna get the accounts that we're gonna work with. For the initialize instruction, we need 3 specific accounts. Okay, 3 specific accounts. The first one is, of course, we need the payer or the user. All right, we need the user account and the payer account. You know what? Let me label that fam. Okay, payer. Then after you get the payer account, that's number 1. Let's get the what? The add account, or let's call it state account. Okay, still following? Then after you get the state account, we need the system program account. So once again, a program in Solana is an account. All right. So we need 3 accounts, and those are payer, the state, and the system program account. All right. Now, what I'm going to do is I'll get that. I'll get the accounts. From where? From the accounts that is passed in our entry point in Solana. Okay, so they give us an accounts slice or list. So I'll unpack that. Okay, so I'll do this. Then I'll say accounts.ether. Then I'll get the first account. Oh, I'm lagging. Come on. Work with me. Okay, there we go. So I'll get the pair first. I think pair equals next account info. There we go. Muy bien. Beautiful. Okay, next account info. Accounts ether. Let's see if that errors, or it has to be a borrow, I think. Oh no. It has to be a mutable count ether or a mutable. Use there. Got it. So it has to be a mutable accounts ether. There we go. Remove this. We're good. So we got the pair already. Okay, we got the pair already. We can get the state in the system program. So I'll do this. I'll get the state and get the system program. Okay. So what part are we already? We're here in this part. Okay. We first get this serialized data and we unpack data. And where do we unpack data? Using Borscht. Okay. We unpack data using Borscht. And we add a cry emoji because there are no more data babies. No more data babies? Why? Because we unpack the data. Hi. All right. Then after we unpack the data, what's next? We get the account. So that's part of unpacking data. Okay, what else? What else do we do after unpacking data? We do our logic. All right, we start doing our logic now. Okay. So let's do our business logic and let's get our argument data because we need to get our add 1, 2. No, this is initialized. We just need to create an account for this one. Yeah, okay. So what I'll do is I'll call a system instruction that creates an account. I'll cheat a little bit. I'll get my instructions so we're fast. So here, let me get the create account instruction from my other program. Okay, let's name this the state account. Why is your NVIM lagging? What's your LSP for Rust Analyzer? It burns my memory. It's like 32 gigs. Yeah, but there's a lot going on behind the scenes in my laptop. That's why it's lagging right now. All right. So what I do here is I simply create an account. But it doesn't know what's the shape of our data store or an account. How do you do that? How do we tell it what's the shape? We create a struct. So above here, I do a struct. So pub struct state. Okay, and then we sum equals a U64. All right, let's do a U64. And we make it serializable and deserializable. All right. I think I'm missing something. Cons, I think I need to implement a len. Yeah, I need to implement a len. So I'll implement a len for our state struct and name it as a U64 or U size. I mean, this is a U size. A U64 is 8 bytes, so we name 8. Why is that important? Because when creating an account, first things foremost, you need to know how much rent you need. So a rent is the amount of money or soul that you need to host a data account. All right. And we do that through what? This instruction. So I'll add here state len. So we need 8 bytes of rent worth. Okay. This is in Lamports, by the way. Lamports is the smallest unit of Solana. What's next? We need to reserve a space. How do we know how long? It has to be state len in space size. So it's how much? 8 bytes stored on chain. Okay. So this is 8 bytes plus rent times rent fee per epoch. Yeah. We create the account and just add the necessary argument. So I'll just add it here quickly. We need the state PDA, the address of the state container or data store. We need the state account info. We need the state bump. You learn that when you go into PDAs and go deeper. Just think of this step as me adding the necessary arguments. All right. What would you notice in here, in this line right now? We have 3 red lines. What do you notice? They're all red lines related to PDA, or what we call, okay, PDA equals program derived address. So we need to get the program derived address of our state, as well as our state bump. How do we do that? Let's do the trivial way. Let's use Solana's built-in find program address function. So for example, I name here state PDA equals find, let me, wait, just getting the, so it's faster. There we go. I have the, how to say this, the function here for finding the program address. Okay. So we have the state PDA, and then it also returns the state bump. You'll learn what a bump is when you go deeper. I'm sure you will. I'll leave that up to you, what a bump is, or with the Q&A later after this session. Okay, then I'll add the necessary, once again, the necessary details that is needed. For now, just think of it as me adding the arguments once again. So for example, in order to find program address, we need its seeds and its program ID. So seeds are the data that we use to derive the program address, program derived address. So we do it such as this way. Okay, then I'll add here payer as ref and program ID. This should be good. Payer.key, I think. Okay, beautiful. Now we have the state PDA and state bump. We can now use it here. Okay, so we use the string state, then we use the bump. It should remove all the errors now. All right. So once again, going back, what we did, we first deserialized and unpacked using what? Borsch. After unpacking, we match what instruction that we have. Specifically, we have 2 instructions. Okay. So we have initialize and add. Currently, we're doing initialize. So we're going to do initialize. We unpack the accounts as well. We got our PDA and we create an account for our data store. All right. The next thing is we want to write to that data. So let's fetch the data. How do we do that? We say state raw bytes equals state try state that try borrow mute data. Yeah, so we get the data, the raw bytes on chain. It has to be so we have the raw bytes. Then we have to serialize, or I mean deserialize or interpret the raw bytes. How do we do that? We state data equals we once again use Borsch try from slice the raw bytes. Okay, so now we have the state data. Okay, the state type. All right, that we have where defined ups. We've defined this state struct up top here. Oh wait, moving too fast. Moving too fast. State. Here we go. We defined it here. Oh, laggy. Choo-choo-choo. Yeah. Here's our definition of a state. So we go back there. Okay, let me comment this out. So that's the state. So we know it has sum. Let's access that sum. Let's initialize that to 0. Okay, so state data that sum equals 0. Should be working. Forgot to unwrap this. Okay, should be good. You're Gucci. All right. Now, since we've already created a data store account, let's store that there. Let's store our state data on that data store account that we've just created. All right. So what I'll do is what it's called. I think it's state data that serialize to state data. I think it's mute is an ugly line. State data. I think this is it. What was it? Mute. And need to turn it into a slice so it implements right. It's in the raw bytes. It's not on the state data. We need to store it back to where it came from. So on the raw bytes. So I'll do state raw bytes. This should work. If it doesn't, I should quit Solana. And just like that, our initialize instruction is finally done. All right. So what do we do next? Do we test or do we create the add instruction first? What do you guys think? We have 30 minutes left. I think we can create the add instruction quickly. I'll do it. Let's do that. Right, okay, let's do that. I'll create the add instruction. I'll just copy the initialize instruction. Okay, just so we're fast. And then I'll remove the system program because we don't need it. I'll remove this. I'll keep this state PDA. I'll remove the create account instruction. We'll still fetch data. But this, okay, got it. We forgot to add more data on our program instruction, enum. Whenever we call the add instruction data, we also need to have what? Two numbers. Let's call them A, another U64, B, another U64. Okay, so we have two U64s. Let's add them. Let's get them here. Okay, so they should be here. Got it? So we deserialize the data. Then what I'm going to do is I'm going to add them and store them into the sum. And that should be our add instruction. We good? We good. I think I can remove this. Ideally, we need to have some sort of validation here is needed, but not right now. All right, so I'm gonna add the same thing above, because once you get the data, once you unpack them into interpretable data variables, you must validate. But for now, validation takes a lot of time when it comes to Solana program. So what we're gonna do is skip that aspect, skip that part for now. I'm gonna go back to testing. All right, this is the part I love the most because our vision comes to reality. Okay, we have two instructions. Once again, we have the initialize and we have the add instruction. We parse this with Borsch, we deserialized into two instructions, wherein in the body of these instructions, we do some hullabaloo, we do some things. All right? So the next thing we're gonna do is I'll do some tests. Okay, let's do it. Oh, still lag. All right, so I'll get some module below, name it tests. I'll add config attribute above this module named test. I think test. There we go. I'll add a test. For example, how do you say this? A sanity check type of test that simply shows us, okay, your tests are running. So I'll do that. Do I install? Okay, I'm finding if I installed Tokyo. Because it's in SPL token. Let me install another dependency. It's called Tokyo. It simply allows us to test asynchronously. So I think not asynchronous, parallel, it seems, for this one, for testing. It lets us test in parallel. So I'll install Tokyo with cargo add Tokyo. It could be a dev dependency, actually. Okay, not sure result. Okay, we're good. Hiya. Now let's run tests first. The sanity check. Let's first see if our sanity check is good and working with cargo test SBF. Guys, if you have burning questions, if there's anything you want to know when it comes to blockchain engineering, Web3 development, Solana, EVM, please ask them right now in our comments or attend our weekly every Thursdays, 8 p.m. PHT. We always host a Web3 Classroom session where we teach you guys how to be blockchain engineers little by little. So this session is going to go, or Web3 Classroom series is going to go forever because it's going to be a continuous, consistent journey of trying to unravel blockchain and Web3 technology with you guys. Hopefully, by the next sessions, I'm no longer lag. I find it interesting that I'm lag. I wonder why. Is it my memory? Let me check. Is it my memory? Our memory is good. It's green. Maybe StreamYard. Yeah. So IT Renzo asked, why is your NVIM lagging? Yeah, honestly, I don't know at this point. I gotta check later on and see why. But let's wait for it to compile. When Rust compiles, I honestly rarely move because maybe it's just my laptop, because it's not that strong. But I need to wait for it to work. So yeah. Any questions so far, guys? If you have questions, please comment down in our YouTube comments or through our stream comments. I'm more than happy to answer and share insights into Solana programming, specifically native Solana programming. Almost there. Just building four more. While we wait, you know what? I'll just to be efficient, I'll get I think the tests. Yeah. I'll get the test function here just because it's faster. Put here. What? There we go. What's the name? It's add. Yo, what's up? Add. We need to add another dependency, guys. It's called Solana program tests and Solana SDK. So Renzo asked the question. It's a really good question. So let me share my insight into why I believe Solana or native Solana is actually better than Anchor. The easiest to understand is that Anchor is actually a painful abstraction because it takes away from all the understanding that you need for you to write great Solana programs. Simply because it does so much for you. And the way it does things for you is it doesn't it's the way we think of things is sequential. Step 1, step 2, step 3, step 4, step 5, step 6, step 7 until step n. But okay, Anchor does it in such a way that it's not actually imperative or sequential. It's kind of hard to follow the flow with Anchor for most beginners. Okay, so that's the first thing. It actually confuses them much more than teach them. Second thing is that I like to be, what do you call this? I like to be in control of my destiny. I like to manifest my own destiny and take control of my outcomes. Meaning, when it comes to Anchor, it's like you're relying on someone's skill to get you out of the dark. You're relying on someone's skill to get you out of a rut. Okay, I know that's normal in engineering. We rely on a lot of things, packages, supply chain. But when it comes to program, I believe programs are small enough and high risk enough that you need to be the one in control of almost everything that you can. Because you're responsible for the outcome of your smart contract or program. So using native Solana ensures that you do that and you are within capacity and you are empowered to do that. Okay? And I hope that makes sense. And the last one, my favorite part, are optimizations that you can do on Anchor. Yeah, so there's a lot of that. And I've been going deeper and deeper and deeper in those, and it's been fun. And it's one of the things that I enjoy about Solana. So that's part of it. In Anchor, I wouldn't be able to do that. A bonus as well is that in order for you to progress in Anchor on the bleeding edge, you need to wait for the tooling to come out. Let's say if we support a new standard, you need to wait for the tooling to come out. As opposed if you just program in native Solana, you're the earliest. You can be a first mover. You don't have to wait for Anchor Lang's release or Anchor Lang's documentation, Anchor Lang's guide. You can start there and then. All right, so going back, okay, I think this should resolve the errors that we have. Did it? Not sure if it did or this is just Rust Analyzer lagging. Because it happens. It really happens. Let's see. Just getting the imports, guys. That's so we're fast. We skip the parts that are not important. Now, after creating a program, let's write a transaction to interact with our program. Okay, so let's start here. Let's find the PDA of our state. So I'll just do this. So it's fast. We'll do an initialize instruction first. Okay. Damn, I think this is Rust Analyzer lagging on me. Yeesh. That's an instruction. I serialize instruction data. Put it in the instruction data. Attach it in our instruction over here. Add the accounts. So let's go back to accounts. This is just test, guys. This is just me trying to send a transaction. So not that important here because most of the testing you're gonna do or the interactions you're gonna do are on a JavaScript most likely. So I'm just setting it up so you guys can see. So the first account that we decided we needed on a program level was the payer. Okay, so we destined that. Okay, we wanted the payer first. It could be backwards. Let's say we get state first. So when we get state first, we need to send state first. So I go here, do this, then I send state first. Then get payer, then get the system program ID, the system program account that's responsible for the create account instruction. So you need the system program in order to be able to create an account. I can show you later that it'll fail if we don't have this here. Okay, so this is a transaction. Once we do the transaction, let's send the transaction. It's state. Is there something I'm missing? Oh. There we go. I think, yeah, state PDA. Then you know what? You know what would be interesting? Let's create two instructions. Let's initialize, then add. So what I'll do here is I'll call this init instruction. Okay. Then we name this init instruction data. Then init x to init instruction data. Then we do the same for initialize, for add. So let's add ix, add ix data. We do this add. Let's make A, right? A to be 1, B to be 2. Okay. Add X. So add anything else? Program ID. We're good. Okay, we're good. So let's create 2 instructions. Okay, so I'll first initialize. So any instruction data, add instruction data. What accounts are we expecting for add? Payer and state. No system program ID. So I'll remove this. I'll switch this. This should be good, I think. Just come. I'll add the comment here just so we have a reference later. We don't get confused. If everything goes well, okay, our test should say that our sum, okay, our sum let's do this so it's we're lagging. That our sum, let's do first num equals 1. Let second num equals 2. Let's put here, okay, first num dot clone, because we don't want it to take ownership. You learn that once you learn Rust. Dot clone. Because we're inside a match statement. Lol. Why is it not supported? You lied to me, brother. Why is it not supported? It's not supposed to be here. It's supposed to be on our instruction. So here, lol. So it has to be let first num equals 1, let second num equals 2, then we name the A, B as first num 1, and second num 2. We need to clone it. Okay, we need to clone it because it will take ownership. Then what I'll do is let sum equals first num plus second num. Okay, sum equals the state. Let's say state that sum that we got on chain should be equal to sum. It should, yeah. Just to be more verbose. If everything goes well, this should pass. Okay, I think we're ready. Let's see. So what we're saying here is that after sending an initialize instruction and then after sending an add instruction, we check the data on chain using this command. So we got the data on chain, and we're saying here that the sum should be equal what's on chain already. So if it's equal, it means our transactions in our programs work as expected. Let's see the test. Why is there a blocking? I think it was analyzer. Let me do a quick cargo clean. It always blocks. Let me see my activity monitor. Okay, let me close this quick. But it blocks my building. It's annoying as hell. There's so many bugs with Rust Analyzer. So, yeah. Nothing I can do about it. So let's test. Okay, this should pass. If this passes, we're finally done. We can go to QA. You know, I'm so happy if this passes. While we wait for it to compile, do you guys have questions so far? With what we did? All right, I'll go over the run through, but this is just all testing. Okay, so I simply sent a transaction saying initialize, then add. And if everything we've done is correct, it should work the first try, or I should quit Solana. If it doesn't work the first try, I will quit Solana. Lol. And what I'm gonna do it is I'll open a new repo. While we wait, I'll open a new repo. Add program. It's gonna be public, open source, so you guys can see it. Then I'll persist the code. Oh my god. Guys, this is gonna take a while, so I can take questions. If you have questions, please do let me know. But we're almost there. Okay, we're almost there. While we wait for it, any questions, guys, regarding what we just did? I know it's a long session, and I'm really happy about the people who stayed with me. I hope it was valuable and you learned a lot from our session today. And I was able to show you at least a high level to medium level overview of how to build a native Solana program, as well as the reasons on why a native Solana program is advantageous over Anchor. No hate on Anchor. Definitely know there's a crowd for Anchor. I can do Anchor, especially for some companies and clients and projects before they wanted Anchor. But me as a preference, I prefer native Solana. And soon, I'm gonna go deeper. Yeah. I'm gonna teach you guys the deeper from Rust native Solana. So it's gonna be fun. It's gonna be insane, amazing. Okay, it's gonna take a while. I think 5 minutes. So because I cargo cleaned. I cargo cleaned. Hi, yeah. NVim config, sure. I'll humor you, Renzo. While we're here, I'll show you my NVim config. I actually have a shortcut command. I know it's Vim config. It's not nvim config, it's Vim config. Here are my plugins. Fun fact, Lua in that Vim. I divide it into LSP settings because it's too bulky to combine LSP plus plugin. Here I have all the configurations here. So yeah, Vim config. I would say my favorite keystrokes on Vim are. Wait, is my keycaster good? Maybe I could try keycaster. Is it working? sucker. My keycaster's not working. Well, let me exit that real quick. Okay, let's go back and check if our guys gonna take more questions, guys. If you have, what do you want me to show you? What else? Vim tricks. I can show you some Vim tricks, fun Vim tricks you can use to speed up your productivity. What's my favorite? For example, do you know VIW for Vim? It's one of my favorites. It's getting the word in between two closures. So for example, quote, there's a word in between, I can get the word in between. See? Or I can delete the surrounding. Watch this. Or I can get the whole block. Or I can delete until D. Or delete until with D. So very, very fast. What else? My favorite things in Vim. For example, I need a repeating line. I can do this. Or I need to, let's say, jump. Can do this. Or let's say I wanna copy this, delete this, then paste it. Right? Yeah, blazing the past. Yeah, man, dude. Although I have doubts in terms of how much productivity we get back from using Vim, but me using your keyboard only is actually beneficial for my ergonomics. I would much rather type than use the mouse. So yeah. How are we? Okay, we're halfway through, guys. Any more questions? Anything you want me to demo with Vim or Solana? Solana optimizations, I can teach you. But it's native Solana though. I can show you my submission in Global Talent Olympics for you to see what it's like. The size of a program. Here's the size of a program on Solana. Let me. It's really big, honestly. Solana. Right. And I can show you the validations. So you have an data validations. For example, account validations here. I do a lot of that. See, these are all validations before I even go to the meat and potatoes of my instruction, which is to create a program update state. So lots of validations happening. I use a macro called require. You can check it out. Here's a macro that I use for the validations. Yeah. How are we? Okay, we're 400 over 600. Almost there, guys. Hopefully you see this, match up and pass. It's gonna be a big win for us. First run. First run we passed. So that's a solid proof at least of our performance in so. If you're here, guys, share the stream, subscribe to our channel, and hopefully you've learned something from our session today. I'm just not sure with the quality because it's lagging on my side. So I'm still hoping though that the audio is good enough for you to follow through the lesson. It's a 2-hour session. EVL to Solana guide or tips. Oh, I love that. If you're coming from EVM and going into Solana, the tip I'll give you is that EVM has high TVL, meaning total value locked, and the price of one token is way higher than Solana. So much of the clients or engagements that you're gonna have and deals that you're gonna have are way higher in price. So let's say my 7-digit deals came from EVM. So yeah, that's the tip I'm gonna give you because you need to think about that when you migrate from EVM to Solana. EVM, you get richer faster on EVM. You get richer and bigger in the long term if you prioritize Sol. But that's personal to me because Sol is in complete alignment to where I want to go. So I know it's beneficial, even if I say no to the high payouts, high value that people offer in EVM. Because let's face it, EVM's eats prices way higher than Sol's. Dang, lagging. Lagging. Where am I lagging on your end? Audio is clear. Thank you, Lord. All right. Any more questions that for Solana, EVM, blockchain engineering in general? How to thrive as a Filipino blockchain engineer? Because that's a factor to be a Filipino engineer. Your approach as a Filipino engineer is different from what the approach is of someone who's on the western side of the world, or from India, or from Ukraine, Germany, from Silicon Valley. It depends. So there are certain things you need to think of and make sure you're aware of when you're want to thrive as a blockchain engineer from the Philippines. Yeah, there's a lot of that. Maybe we can host a session around that. Almost there, guys. Woo woo. Hopefully, the first try passes so we can say goodbye to Solana and Ross for yeah, almost, almost there. What else for Solana? What can I give? A lot of L2s, a lot of layer twos, roll ups, gaming is coming to Solana. So that's one thing you guys can position and capture the value around those. Warb, this is the last try we're gonna do once this run, whether it fails or it succeeds, we're gonna bounce. But let's make this run first, even if we overtime. Hopefully it succeeds. Come on, Sol. Give me this first try success. Sol, give me this first try success. Oh, give me this first try success. First try success. Sol, give me this first try success. First try success. Give me this first try success. Give me this first try success. Let's do it. Almost there. We're just 641 away. 41 units away, or packages away from being fully compiled and running. So, guys, okay, let's wait. Almost there. 36. Countdown with me in the comments. Come on. Countdown. There's a lot of that. Yeah. Give me the first try today. The first try today. Give me the first try. If this really passes the first try, I'll be like, oh, coolio. Or we never know. There's always something unexpected that I missed. Maybe the ordering of accounts, maybe the serialization or the serialization. Huh. Possibly it could be a signer problem. Yeah, but whether this passes or fails, we're gonna just continue in another Solana session eventually. But the next one after this is not gonna be Solana. Stay tuned for that. That's EVM, I think. So high TVL, lots of opportunities. Enterprise companies go for EVM. Some enterprise companies go for Solana, but more on the token extensions, financialization aspects. So yeah, go in the EVM session as well. Learn a lot from that. It's gonna be someone who worked at Protocol Labs. So IPFS, if you guys know, from Protocol Labs, he worked directly with the company as a really high position as well. So fun, fun. Okay, give me this first try you pass. First try you pass. Give me this first try you pass. First try. Come on, redemption. Give me the passing. All right, 10. We're 10 packages away. Sol. Give me the win. Come on, Sol. Solana. I channel my inner Dean. Jumper Jam. Bird. Anatoly. Chase. Sturt. I'm channeling all my J Starry. John Sinke. Sinke? I think John Sinke. Who else? People I look up to. Febo. Almost there. 6 packages. Come on, Russ. Move it, Russ. Waiting. Channeling my inner Dean. Dean. Doc kick. Oh, fuck. First try failed. Wait. Let's see. Air.key is not found. Yeah. I think it has to be pub key because it's from the context. I think. Let's try. No more errors. This better work. Last try. Let's do it. So first try didn't work. Let's see if second try. Give me this win. So pass on my second try, please. Let's go. Ah. Third try. Third time's the charm. Yeah. I forgot to add async keywords on our sanity test. This should work. Come on, Sol. This is the last. If this fails, I'm gonna say goodbye. Okay, everyone. Once again, my name is Kristian Kirapas. I'm the president or co-founder of Web3 Philippines. We do these sessions every Thursdays, 8 p.m. Philippine time zone. If you want to join in, you're free. It's streamed across all our channels, and our goal is to onboard more and to teach more people, especially Filipinos, on how to build and be part of blockchain technology. So it errored. I'm tempted to, but I'm not going to. All right, guys. I hope you learned. Thanks so much. See you next session. Bye. First try. Didn't work first try. Hey, first try.